So hello everyone, in this video we'll be covering solution for question 2 endsem exam. So let's see the question. It states that write an algorithm that uses Bayes theorem for decision making. So an algorithm is written. So first step of this algorithm is define hypothesis, like identify all possible outcomes or states relevant to the decision. Example, hi H1 customer will churn, H2 customer will not churn. Then gather prior probabilities. Assign initial probabilities to each hypothesis based on existing knowledge, historical data, or expert opinion. Then observe evidence. Collect new relevant data or observation that provide information about the hypothesis. Example, customer has recently interacted with support and website activity has decreased. Next is determine likelihood, which is a probability formula. For each hypothesis, determine the probability of observing the evidence if that hypothesis were true. This often requires domain expertise or data analysis. Example, P of E by HE, probability of observing E given the customer will churn, P of E by H2, probability of observing E given the customer will not churn. Next is calculate marginal probability of evidence P of E, which means calculate the overall probability of observing the evidence across all hypotheses. Next, apply Bayes theorem to find priorities probabilities and then make decision. Now let's see what is Bayes theorem. So the naive-Bayes classifier outlier algorithm states that first is input, training data with features x and class labels y and a new instance x star to classify. Then estimate prior probabilities p of y equals to ck for each class ck from training data. Next, for each feature xi and class ck, estimate likelihoods, like calculate the probability of this. In naive Bayes, we assume conditional independence between features given the class. Then, for the new instance of x star, for each class ck, compute the unnormalized uh, poster, posterior score. Which the score formula is p of y equals to ck multiplied by uh, pi of I, p xi equals to x star I of probability of y equals to ck. Next, choose the class with maximum score. This. So output will be predicted class y star for x star. So this is a Bayes theorem, naive Bayes theorem outlier. Now let's see next question, next part of this question, which states that write any suitable algorithm for association rule mining that can print all association rules. So algorithm define minimum support and minimum confidence. Minimum support is the minimum frequency an item set must have to be considered frequent, and the minimum reliability an association rule must have. Then second, generate frequent item sets. L1. Scan the transaction database once to count the occurrence of each item. Filter out items whose support count is less than min underscore sub. These are the frequent one item sets. Then iteratively generate frequent k item sets. Then lastly, generate association rules from frequent item sets. Now let's see an algorithm, which is an a priori algorithm. So first step is our input, transaction database D, minimum supports min sub, minimum confidence min conf. Then generate frequent item set using a priori. Find all one item set whose support is greater than or equals to min sub. Then next, for k equals to 2, 3 and so on, generate candidate k item set by joining format k minus 1 item set with each other. Then prune candidates whose any k minus 1 dash subset is not frequent. Scan D to count support of each candidate. Keep only those with support greater than equals to min sub as frequent k item set. Stop when no new frequent item sets are found. Then third step, for each frequent item set L greater than 2. For each non-empty proper set of A, let B equals to L minus A. Then compute confidence support of L by support of A. If confidence is greater than equals to min con F, output association rule with its support and confidence. The output will be all association rules satisfying min sub and min conf. So this is it for question 2. We'll be seeing next question in another video. Thank you.